Good morning, madam. Parvata, madam. Parvata, madam.
Good morning, sir.
Good morning, madam. Good morning, madam. Ma'am, once things are ready, let us start the session, madam.
Sure, sir. We have to wait for some 5 more minutes, sir.
Okay,
Many
madam.
many students are joined now.
Okay.
So, okay, sir.
Let them join, madam. We'll wait for a couple of minutes.
Okay, sir. Sir, shall we start our session, sir?
Yes, madam. Madam, any introduction or formal program is there, or shall I start the session?
Yes, sir. Yes, sir. Introduction session is there, sir. Madhumita?
Yes, ma'am. Okay. Good morning to one and all present here. It gives me immense pleasure to welcome you all to this special occasion. A hearty welcome to our distinguished Chief Guest Dr. S. Ravi, Associate Professor at Sheshadri Rao Guruvalleru Engineering College, Andhra Pradesh. Dr. Ravi is an accomplished academician and researcher with more than 17 years of rich teaching and research experience in the field of VLSI design and FPGA technologies. He holds a doctorate in VLSI design from Anna University, Chennai, and he has remarkable contribution in both teaching and research. His professional achievements are truly inspiring. He has authored 2 books, 4 book chapters, and published more than 40 research papers in reputed SCI and Scopus index journals. His expertise extends to advanced areas like CMOS VLSI design, embedded systems, and low power circuit design. He also guided numerous student projects, delivered more than 30 guest lectures across prestigious institutions. I extend a warm and respectful welcome to our CEO, Sir, Principal, and Head of the Department and faculty members. Last but not least,
Hello.
welcome our chief guest. I
Yes, madam.
wholeheartedly welcome my fellow students whose enthusiasm and participation makes every moment meaningful. Once again, I welcome you all and look forward to a memorable and enriching session ahead. Thank you.
Thank you very much. I hope everyone is in an enthusiastic way to learn this system Verilog programming. As there are many members, almost 100, I could see in Google Meet itself, and Madam also says there could be 100 more students or more than that in YouTube. At least I would like to hear some kind of inputs during the session of discussion. Okay, so without wasting much of our time, let me start the session that we are going to speak about system Verilog programming. Is my screen visible to all of you? Some of you please unmute and speak. Is my screen visible? Madam? Pavitra ma'am?
Yes, sir. Visible, sir.
Is this right, madam? Sairam Engineering College.
Yes, sir. Visible, sir.
Okay, madam. So, happy morning to one and all participating in this wonderful program on hands-on session in system Verilog programming. Myself, Dr.S.Ravi, already a resource person might have told qualification and experience and so on. I would like to start with what is the importance of system Verilog programming in the market today. Okay, there is a reason behind this because Pavitra Arvata madam asked me to speak on this also, like what exactly happens in the VLSI industries. Okay, actually one sample I have shown here. As you can see, there is a company named Renesas. In that, they are looking for some fresher or recent graduates or having some minimal experience who can perform RTL design through Verilog or VHDL. Please understand this, either Verilog or VHDL, and they should have some experience with respect to simulation, how to verify a design and its synthesis aspect. That means how to implement your design into hardware. Normally through program, we write it into software tools that must be implemented into hardware. There are two aspects. One is FPGA implementation, another one is application specific IC, integrated circuits, application specific IC. So here it is mentioned FPGA, as you can see. and collaboration with the design teams. So design means the requirement may come from different companies, maybe in a chemical industry, maybe in a mining industry, or maybe from military. So in different situations, there will be different kind of design teams. We should interact with them. We should try to identify the specification, what is possible through our hardware implementation or design aspects. Okay, so you should be familiar with the FPGA implementation. There is one more aspect called ASIC, application specific integrated circuit. Okay, so out of these two, FPGA is the most commonly used. You all know the reason behind this, because it is easy to prototype and verify your design physically, right? And the qualification and all, as you can see, either BTech or MTech, both are equal, right? All it requires your skills. Your skill decides your destiny in case of VLSI industries. Okay, and I suggest you one more link here in the PPT. After the completion of session, I'll share the PPT. You can note down this link and please go through this link. What are the job roles available in VLSI industries? Okay, like FPGA engineers, ASIC engineers, verification engineers, testing engineers, different roles are there. You please go through all these things. Okay, as of now, what I would like to say means there are openings in VLSI industries, and you should be knowing what are the skills required to enter into these industries. Is that okay? This is the first thing I would like to clarify here. The next thing, as Parvata madam spoke to me about system Verilog programming, they are interested in these aspects, especially the second unit or second module, where processes, system Verilog threads, fork and join, function, task, inter-process communication using mailbox, semaphores, followed by interfaces, right? Mod ports, clocking blocks, all these things are coming in module 2. So madam asked me to give a complete picture of this, what exactly it is, with some sample programs along with hands-on session. That is what the intention of this discussion today. Okay, so as a part of this, I would like to go with where all these things starts from, the point from where all these aspects come. Okay, first thing, we as an electronics engineer, in the first year of our study, we go through about devices, right? Maybe BJT or MOSFET, because in recent days, most commonly we use, I mean 90% I can say, we use only MOSFETs, right? So we study its construction, operation, how it works with the different voltages, all these aspects we study. Then later, we move on to how to interconnect these transistors in order to build simple logic gates. What you see here is a NOT gate. You may go for interconnection of PMOS and NMOS transistors in order to build a NAND gate and NOR gates, right? Some set of logic gates we build. And these logic gates put together, we construct combinational logic. Maybe adder, subtractor, multiplier, divider, comparator, and so on. This we normally carry out in our second year. In parallel to this, maybe digital circuits, you may be studying analog circuits also. But basically in the first year or in the second year, first semester, we focus on EDC, electronic devices. Then later we move on to digital circuits. Once we understand how the adder works, how the multiplier works, we move on to interconnection of these modules to study about microprocessors, right? Microprocessor means it involves major blocks like ALU, timing and control unit, set of registers. Can somebody please tell me what are the modules available inside this ALU? Some of the operations carried out by ALU.
Adders, subtractors,
Good.
comparators,
Okay. Normally this arithmetic and logical operation, we speak about addition only. Please include the logical operation also. Okay. And or not, XR, all these logical operations also carried out. Whatever you have mentioned comes under arithmetic operations. It also performs logical operations, comparison, string manipulation, Whatever the program you write in C programming, most of the operations are being carried out in hardware, right? That is our ALU, heart of the processor. And inside that we have set of registers also. Do you know what is the purpose of registers inside a processor?
To store the data or to shift the data.
Very good, very good. So a processor having a processing unit called ALU, a core unit, but it needs some inputs in order to process it. Once it processes and gives some result, right, that result must also be stored somewhere temporarily. That for that purpose we use registers, right? You might have studied about 8086 or 8085 microprocessor, which has some general purpose registers, special purpose registers. These are common not only in 8085, even if you go for core i3 or core i7, i5, i9, all these things will have set of registers. ALU, one more important module is there. Can somebody please tell me what is the important module? Timing and control unit. What is its role? Timing and control unit. Timing and control unit.
Sir, timer is used to calculate the time for one instruction performed by the processor or a controller, sir.
Okay, any other answers? A reasonable guess? Something else? Timing and control unit.
Purpose.
Pardon?
Synchronization purpose, sir.
Very good, very good. Synchronization, very, very relevant answer. We must understand one thing. ALU performs the operation and register storing the operands and the results, and there must be an unit which tells what's supposed to be done by each of the elements inside the processor. If there is a register, I want to write something into the register, I have to enable and say, then only it will accept new values. Similarly, if ALU is there which can perform multiple arithmetic operation, I should say which operation you have to perform at this moment. So it controls as well as on a specified time. At this time you perform addition, at this time you perform subtraction, right? So all these are given instructions or commands to carry out what operations to be supposed to be carried out, and also on a timely basis, right? This is what timing and control unit is. And of course, this implementation of ALU, registers, timing and control unit you might have studied. Anyhow, if at all you have some questions, you can ask, or during the time of discussion I will also point out these things. The core idea of discussion, why I come to this point, means after all we are trying to design a processor, right, by interconnecting set of logic gates and writing a program. That program actually tells what exactly to be carried out. The program will be translated into machine codes. That machine codes instruct each and every module inside the processor, right? You write the program must be translated into machine code. Then each code goes inside the processor and activates and says the ALU, you perform addition, and says the register, you accept the result. Not all. It may be enabling A and B register when you perform storing the operands, and it may enable some C register for storing the results, right? So at different times, enabling different components inside the chip, and the whole thing is being carried out in a synchronized way. For that, we use timing and the control unit. Is the idea clear? Are any questions about this?
Clear, sir.
This is what the goal of the whole subject, sir. This is what I cannot say just about system Verilog. This is what a goal of VLSI design engineer. When a computer science engineer uses the processor to execute some program, a VLSI design engineer is the one who designs the processor. Okay, what are the components inside, how they must be interconnected, what are the operations it can perform, all these things decided by VLSI engineer. So I believe as a VLSI engineer we should have this basic idea. Okay, now let us come to the concept here. This is the way we design it. Now what is the need for verification? Sir, I have designed something, I should apply set of inputs and verify it works properly or not, isn't it? So I should verify it. So how can I verify? I supposed to force set of inputs and observe the results. I should have some expected results, compare with it. Once it works, I mean once the results are matching with the expected one, I say that the chip is functioning properly. If any mismatch is there, I have to change my design so that it meets my expectation. Is the idea clear? This is what the idea behind verification. Sir, if not done, what will happen? If I don't do verification, what will happen? I'll give you just two simple examples. From Intel processor alone, we all claim that Intel is the leader, right? In either laptop or desktop processors, Intel is the leader in computer processors. So Intel 13th and 14th generation Raptor Lake processors, they introduced in recently in 2022. What the problem they identified means, they have fabricated the chip, it has reached the market, it is working fine. But the problem is, sometimes it takes excess amount of voltage, operating voltage, because the program what they have written inside the BIOS, you all know that, right? Basic input output system, the static program what we write. So some errors are there in the program, some microcode errors. Due to that, what happens? It is taking more amount of supply voltage. Normally, for example, 3.7 it's supposed to use means it is being given with 5 volts or 6 volts. What will happen, sir, if I apply a device which is supposed to operate with 3.7 or 3 volts, I apply with 5 volts, what will happen? If you try to operate your electrical systems with higher voltages, what will happen? Heat will be produced, right? Lifespan of the component or module will be decreasing, right? This is what happened with the Intel 13th and 14th generation Raptor Lake processors also. Later they identified, and they have sent some BIOS update program also to change it. Many members have changed, but still already the earlier affected people could not be rectified. Whatever the processors which underwent this problem due to excess voltage and higher temperature, right? Those ICs could not be recovered. Only in the initial stage, whoever is suffering, they have taken this update from Intel and they have rectified this issue. Okay, I've given the reference link in order to go through the complete history behind this. And coming to Intel Pentium floating point division, this is where actually the issue started. Why there is a stringent need of verification. Floating point divider, you all know divider, right? Divider. For example, 10 by 2, 9 by 3, some division operation. Floating point division means division performed on floating point numbers, right? So this floating point divider implemented by Intel Pentium processor. Okay, it happened some 30 years before, please understand, not now. Some 1995 around, the problem has started. That means in this particular implementation of floating point division, they supposed to set 1600 cells, 1066 cells with a value between -2 and 2. But what they have done means some 5 cells out of 1066, maybe 5 cells were set to 0 instead of 2. Is the point clear? This is called a lookup table approach, and some algorithm is there, division algorithm is there. They implemented using this division algorithm, and for that there is a lookup table for calculation of division. In that they supposedly enter the value of 2, instead of 2 they placed 0. When you verify for some input conditions, it may give proper results. If you do not verify for the required input conditions which shows the error, you will see that okay, the system is working properly and you sell it into the market. But what they have carried out, it cost around $475 million for Pentium, Intel. Okay, as a compensation, whoever has purchased it, they have to compensate by giving this money. Is the idea clear? So if you do not verify your design at later stage, if you understand the problem, the cost will be very, very high. You keep many people to sell your product, but if there is an error and a complaint comes from the customer, the amount you spend will be more than what you receive from the customer. Is the idea clear? Any questions up to this? Shall I proceed?
Yes, sir.
Okay, thank you, madam. Madam, I take this is much of my time I have taken about the importance of this subject and the purpose of verification. Let me move on to the hands-on session, madam. Shall
Yes,
I?
sir. Sure, sir.
Okay, so let us move on to the key idea here, the test bench. In order to verify the functionality, we write the program test bench, where we generate set of inputs. You drive the inputs into your system, and once it gives the result, you compare with the expected one. If there is a bug found, then we have to change your design. Else, we proceed. This is what the key idea behind the verification, what we are going to do. And there is a comparison between Verilog and system Verilog. If I take on this particular concept, I'll just go with one or two concepts here. Okay, then immediately we'll switch over to the hands-on session. So when already some members may ask me this question, when already Verilog programming is there, what is the need for system Verilog? Verilog, of course, an existing language, most commonly used language, but from verification perspective, right? Applying various corner cases and self-checking design. Self-checking means instead of looking at the waveform, what it normally creates, I suppose to read the final result. Everything must be carried out. All input combination must be applied. Whichever input combinations there is an error must be reported to me. This is not carried out through Verilog, but it is carried out through system Verilog. Okay, so for that we should have a free way of writing the program. This is not possible with the structured programming. It is possible only through object-oriented programming. Okay, so system Verilog is influenced by C++, whereas Verilog is influenced by C. Okay, so that you please keep this as a key difference between Verilog and system Verilog. Verilog follows the syntax of C, while system Verilog follows the syntax of C++. I mean, most of the modules or programming constructs follow C++. Okay, like different data types are coming in. It supports classes and object concepts. Okay, let me just move on to the practical session. I'll just share the link to you through chat box. Some of you who are in Google Meet may access this link. You can click on this link so that you get the module like this. Madam has already told me you all have EDA playground with you. Are you all following? Some of you may unmute and speak.
Yes, sir. We are following, sir.
Okay, thank you very much. And I ask some of the students to post some questions. Any general questions do you have till this moment about Verilog or about digital ICs? What is verification and other things? Any general questions? If not now, even if you get it during the course of discussion, please feel free to ask. And also use some paper and a pen. You note it. Whenever possible, you ask the questions. Okay? Have you all opened this? Say yes or no. Have you got this link? Okay, thank you. I'll share many links are there because there are many members. There are many members who may be new to this programming language. For them, I have taken this simple example. Okay, this programming language starts with our design called module. Right, the Verilog programming having the syntax of starting with the keyword module and terminates with the end module. The complete details about the design is described inside. This is module name, right? So that you can call this module from somewhere. And check is the name I have given here. And I list out some ports Y, A, B, where Y is my output, A and B are my inputs. Okay, and I specify its functionality. How do I specify the functionality? What is the functionality here? So I perform logical AND operation using operator. Okay, so I assign the result of this operation between A and B. The result is assigned to Y. Okay, The same thing may be declared at the gate level using this instruction. In gate level means always the output variable comes first. So it starts with the keyword module, terminates with end module. This is the program what I intended to write here. Any questions about this? Sir, don't think that I start with a simple program. Things will go gradually, right? If you have any questions at this moment, please ask, because the same you should not ask at the later stages. Any questions here? If no, please unmute and say no, so that I will proceed. Any questions or suggestions, or why not like this? You can ask it now. Any suggestions or questions? Shall I proceed? Vivita,
Yes,
Harshini,
sir. Yes,
Yes,
sir.
sir.
Radhika. See, stay online and interactive. That is the only thing I ask. If you say proceed, I'll proceed. Okay. I have no issues going with the complex modules, but I normally assume that it is a mixture of many students from different levels of learning. Okay. Now I will take you to slightly a complex module. That means I'm trying to write a test bench program now. I want to verify this program, my AND gate, by applying set of inputs. How do I write my test bench? Please listen to this. So what do I do here? I start with the keyword module and terminate with the end module. Okay. And for test bench also, I assign a name called TB. This is my test bench. Does it have any ports to interact with somebody? Means no need. This itself the top level module. Okay. It need not communicate with anything. So I don't declare any ports here. And I declare some 3 variables under this. Output, 2 inputs. Okay. I assign my own name, whatever way I like. Now, normally the input variables are declared as reg in case of top level block in the design, in the test bench. The reason behind this, why I declare reg means, till I write with a new value, it has to hold the previous value. Okay. So once I apply the input and leave, the input must remain there for some more time. Okay. This is the idea behind reg. Wire means every time it should reflect the changes. When I change this, it has to reflect immediately. Okay, so I go for a variable called wire for my output variable and reg for the input variables. And I call my design program here. What is this? Design under test. What is the name of my design under test? Look at the other side. It is and check. So I call by its name and check. And I call with my instance name. Okay, here I am calling once. I may be calling any number of times, right? I just call only once. I give some random name, C1. And I try to map my signals in my test bench into my design here. Please look at the difference. This is YAB. Here I am giving the name output. So this output maps with Y here. This A in maps with A here. Similarly, B in maps with B here. So whatever the value I force inside the program, like applying 0, 0 or 1, 0 or 1, 1, whatever I apply, that will be applied to my design. The design will perform the functionality what is shown here, performing AND operation or OR operation. Then I can monitor the results here. Show me my value of A, B, and output along with the time. I just want to see the time also. So it will show me the time also. Is the idea clear? And if at all I want to see in a waveform, this is for log window, this is for waveform. All the changes in the inputs and the output will be stored through dump variables. These variables, all these variables will be captured, and the result will be written into a file called dump file. Okay, basically it is an ASCII file which stores different values of input variables and the output variables. It is stored into the file. This is in ASCII format. If I supply this dump.vcd to a simulation tool, it will show me in terms of waveform with respect to timing. Is the idea clear? So now I'm going to run this program. Okay, before I run this program, any questions at this moment, please ask me. If anybody having questions here, please ask. Anybody having questions here? Madam asked me to follow YouTube also. Madam?
Yes, sir. Yes, sir. They are following, sir.
Okay, madam. Any questions come from YouTube?
Students, please be interactive.
Okay. Any questions? If you have questions, you can ask. Madam said that people are more enthusiastic. If at all no questions, please ask me to move to the next slide. No issues. Sir, we have understood this. Please take us to the next slide. You have the freedom to ask. You have the freedom to say. Please tell me.
No
Shall I?
doubt.
Yes? Do you all understand this?
Sir, please mute your YouTube video, sir.
Myself?
Yes, sir. Just audio mute, sir.
YouTuber.
Yes, YouTube audio, sir. Well, okay.
Madam, is it okay now? Any nice kind of thing coming?
Okay, sir. Now it's clear.
Thank you, madam. I'll move on to this. Students, please ask any questions from here. If you have any questions, please ask. About the test bench. Shall I run the program? Okay, I run the program. You also please try this. Sir, it is only a sample program. Don't mistake me. I will take you to each and every component from the second unit one by one. Okay. So once you simulate this, there is a log window at the bottom of this tool, EDA playground. Okay. Can you see this one? So at the 0th time, my A input is 0, B input is 0, and hence my output is 0. After 10 units of time, right? 10 units, maybe nanoseconds or microseconds. It is specified in the simulator itself. So here it is 1 nanoseconds. Please understand. 1 nanoseconds. So after 10 units of time, it happens like this. Maybe 20 units of time. Maybe again another 10 units of time. You can change the timing and verify your results. Okay, does it work properly or not? You ensure this. This is one way. What is the other way, sir? So you click on here, open EP wave after run. This is ultimately the goal behind this, right? This is ultimately the goal behind this, right? We want to see the waveform through this program. The purpose of this program block, initial block, is to see the result in waveform, right? For that, we should write the change in values at different times into a file called dump.vcd. Once we have stored into this, now let me run again. Okay. So click here. You can see at this particular instance, 0, 1 means 0. You click here. At this instance, 1, 0 means 0. At this instance, both the inputs are 1, so output will be. So you can give different kinds of input and verify your results. Any questions, sir? Any questions
Sir,
up to
what
here?
is the dump waste one? That one indicate is what, sir?
Okay, thank you very much, madam.
Okay.
Very interesting question. So if I keep 0 means it is nothing but level. If I keep 0 and run the same program, madam, there are only two things: upper level, lower level. If I say 1 means it is only top level. What is the top level block in our design? Test bench is the top level block. What are the variables I declared inside? I have declared only 3 variables: wire, output, AB. Okay. These are the top signals in the top level block. So if I give 1 means only these signals will appear. If I give 1, okay. If I give 0 means it is going one step below. That means depth is more. What is the module we have concentrated here? We have instantiated here. Its leaf cell is AND gate, right? What are the signals available inside the AND gate? As you can see, A, B, and Y. Am I right, madam?
Yes, sir.
So all the leaf cell signals also will appear if I give 0 here. Okay. That means
sir.
instead of checking only the top level block signals, monitoring only the top level block signals, you can also monitor the leaf cells or bottom level modules also.
So only 0 and 1. That's
Yes,
it, sir.
only 2 levels, leaf cells and the top levels.
Okay, sir. Thank you.
Madam, can you see this one, madam?
Yes, sir.
So we have got A, B, Y. These are from the leaf cell. It doesn't mean that, madam, it is because I have written a simple AND gate having 3 ports, so it shows like this. If you write any complex module, all things will be coming. How many different design units you instantiate into here, all will be displayed. So it will be clumsy for you. Are you interested to go only the signals presented in the top block or all its leaf cells? Suppose assume that you have designed a full ladder, madam. I mean full ladder. Full ladder again having half adder means full adder instantiated half adder signals, right? So half adder signals also will come. Full adder signals also will come. Again the top level test bench signals also will come. So there is only 2 levels, 0 and 1. And you have the option to specify the module also, which one you wanted to see. By keeping a comma, you can specify. I just wanted to monitor from test bench, or I just want to monitor from full adder, half adder, like that you can specifically include. So there are parameters which help you to change this. Okay. So as of now, my suggestion is to go with 1 instead of 0, because going 0 will show you every signal. So if at all you want to remove any of the signals, you know that this you can do. Suppose you want to shift the signals down or up, you can move like this. All these things you might have practiced. And radix will help you to change binary, decimal, signed decimal, ASCII, correct? In case of analog experiments, you may go for analog also. Probably we don't do it here. Any questions? Any other questions other than this? So you try to pass 1 or 0. So let me say with 1. I have some more examples to go in the nearby. I'll show you with the changes also. Anything else about dollar monitor? Any questions? Anybody wants to ask about dollar monitor? Dollar display is one-time execution. Dollar monitor means any of the variables listed here changes means this statement will come into execution and display all the values, whatever changes it has shown. Okay, so many aspects are there. By spending more and more and giving more options and trying, simulating, you will get it. Okay, I believe that this is only a simple starting step for our simulation. I'll move to the next one, another sequential circuit. So for sequential circuit, I would like to go with a counter design. Students, please understand that this is the opportunity for you to pose questions. Okay, feel free to ask your questions. Please do not hesitate. Maybe right or wrong, thinking, all these things. Please do not hesitate. Ask questions. Okay, I come to this one. A sequential circuit. Again, keyword starts with module and end module. This is module name I have given because it is user defined. Followed by list of ports involved in my design like clock, Q, up down is one more signal because it's not just up counter, it is up down counter. I prefer to go up down counter. So whenever the reset input is activated, Q will remain 0. Suppose not of up down means it will increment. In the sense what? Assume that the signal value is 0. Not of 0 means 1. Whenever it is 1, the condition will be true, then it goes up counting. So 0 means it performs up counting. Suppose if I keep 1 here, what will happen? If this is 1, not of 1 will become 0. The condition fails. If the condition fails, you come to else statement. That means it is added with the 15. Means what? It is subtraction or down counting. Can somebody please tell me why it is so? Adding with the 15 will become down counting. Any idea behind this? Else you take it as an assignment, you practice it, because it may take some more time. It may deviate from us. Okay, let us a lot discuss here at this moment. Let me go on to the test bench program at this moment. So the one important difference between the aspect of combinational and sequential is this one, sir. The clock module. Okay, because in combinational circuits we have set of signals to be forced to be see the results. But another module is called my clock generating unit. Clock generation unit. So this clock generation is written in the test bench only. It is not a part of our design. Okay, where we force the input, there only generate the clock and force it. Rest of the things will be almost the same. I declare all my input variables as reg, all my output variables as wire, and I have to call the design unit, the design under test, into the test bench program. And here it is the port mapping process they are carrying out. So whatever signal name written here out of the port is nothing but port from the design. Okay, something which belongs to up and down, that is my clock. And whatever I have written inside the bracket, mapping the port with my test bench module. Okay, suppose if I give clock 1 here, I should mention the clock 1. Is the idea clear, or any questions? But if at all I change here, everywhere I should change into clock 1. Wherever in the program I write, I should change here also. So avoiding that confusion only, I have just used the name clock. You may try by changing these values. Okay. Shall I move on?
Sir, can you share the link, please?
I'm sorry. I'll share the link. Thank you very much. Is it okay now? Please click.
Yeah, thank you.
Sir, take your time. Actually, we are going to see everything as a practice. You don't worry about the timing and all. You try to clarify your fundamental doubts. Make this as an opportunity to clarify your fundamental doubts. Why, what, how, all questions must be answered by this session. Madam, somebody could have noticed here. This is test, this is 0. So if I say 0 means, under this module called test, I want to observe all the signals. Not only in current module, under this if I have any leaf cells, like clock, up, down, all these things will be coming. Okay, because I am instantiating my design here, right? So signals related to this also will be monitored because I keep 0 here. Shall I run the program, or any questions? Please ask if you have any questions. And forcing the value is slightly different between combinational and sequential circuit. In case of sequential circuit, we supposed to initialize the clock signal value, because simply we are saying that after every 5 time units the clock gets complemented. That means initially it is 0, means after 5 units it becomes 1. After 5 units it becomes 0. Because it is an always block, it executes till the completion of the simulation. If you don't stop the simulation, it will execute forever. Okay. So somehow you should stop the simulation. So I do this with the help of $finish task. Is that clear? You should stop the simulation, else the clock will be generated forever. So you stop the simulation process through $finish. So after a certain amount of time. So initialize the clock. Initially I am making reset equal to 1. When reset equal to 1, what happens? So Q will go to 0. Okay. After 5 units of time I make reset equal to 0, means it will act like an up-down counter. So it won't do anything. Now it goes to up-down counter. Initially I make up-down equal to 0. Up-down equal to 0 means up counting. Okay. Up counting. If it is going to be 1, then I'll make down counting. So you can change into later after some unit of time, up counting, down counting, and so on. Is the point clear? As usual, we monitor the variables. Like I am just monitoring only Q. In the log window, I just want to monitor the counter value Q alone at a different instance of time. Shall I run the program or any questions? Shall I run, sir? Parvata madam?
Yes, sir. Yes, sir.
Okay, madam. Madam, if at all any things to be added or to be skipped, you please inform me, madam, so that I'll proceed accordingly. Is
Okay.
everything okay, madam?
Yes, sir. Okay, sir.
I'll come, madam. This is only an introduction part with basic doubts about programming. I'll move to the modules one by one. Okay.
Okay, sir.
If at all required, you please urge me so that I will skip this one and I will move to there. Okay. These are the signals what we observe. Up counting goes from 1, 2, 3, then goes to down counting. Again, once again, up counting starts. So 0, down counting. After 0, it goes to 15, then 14. Instead of 14, once again it goes to 0 because it is starting up counting. Because the up down value signals when to 0, it once again starts up counting and up. Okay. So this is more than sufficient to speak about the fundamentals of verification aspects of simple combinational circuits and sequential circuits.
Sir, why that waveform it shows double times, two
Double
times, sir?
time. Yeah, thank you very much. Thank you very much. As I had told before, here there is a signal 0, right? In the dump variables. 0 is there, right? Let me make it 1. Let me make it 1. Okay? You please the difference, see the difference now. I just made it 1. Now I run this program. Thanks for your attention. Can you see this difference now?
Yes, sir.
Actually, what made the difference? What is the difference with respect to 0 and 1 here? Just before I explain, yes? 0 means the low level
signals were
leaf
not.
cells signals also will be accessed. Leaf cells means here the top level block test is having inside a leaf cell called up and down. That's nothing but our design unit. The design unit is having signals like the same name, right? Clock, Q, up, down, reset. If you give it a different name, different names it will appear. Because I have used the same signal names for both my design as well as test bench, I am getting 8 signals here. I'm getting 8 signals. Okay, if at all I go with 1, it deals with only top level block. That means my test. Because I mentioned here, please deal with the signals in test. That means my top level block. So it shows the signals involved only in the top level block. That's why you have got 4 signals here instead of 8. Anything else?
Sir,
Rajeshwari.
in the previous module we
Madam,
have
shall we move on, madam, into the content?
Sir, in the previous module we have mentioned only dump with the variable 1 or 0.
Yes, madam.
Here you have included the test also. Suppose
Yes, madam.
if you are not mentioned the test, then what will happen, sir?
Yeah, nothing will happen, madam. This is an argument we are passing. Okay, this is an argument we are passing. By default, it will take the current module. It will take only the current module.
Okay, sir.
Let me run this program again. Madam, have you got the same signal, madam? Have you got the same?
Yes, sir. The same signal repeat.
So it's an argument, madam. When there are multiple modules, you can specify some module selectively so that only that particular module signal alone can be seen. Okay.
Thank you, sir.
So normally I haven't come across any situation to go with some different arguments. That's the reason I normally do not try with anything else. If at all there is a need, you please change it and try to verify it. Okay. So current module, or you can mention them. These are the arguments we can pass into this particular function. A task. Sorry, task. Anything else, madam? Shall I move on to the next one?
Okay, sir.
Let us come to the syllabus perspective. Pay attention to this. First one, we have to start with the processes. system Verilog threads, and 4 can join. Okay, so concentrating here, and this is another thing I thought of telling, as madam asked me what is the idea behind this architecture. Madam, shall I discuss it at the last moment, or do you want me to discuss now, madam? This particular test-based architecture.
In the beginning itself, sir.
Shall I start now itself?
Yes, yes, sir.
Okay, ma'am. So, students, as I have told, normally we design our systems. Whenever we want to verify it, we write the design program, right? For Verilog, this is structural level modeling, gate level modeling. Then, how we are going to test it? Any complex system, how normally we are going to verify means, this is the complete architecture of verifying any complex system or verifying any of your design using the object-oriented concept, object-oriented programming concept. Okay, this is what our full adder is. This is what our full adder called design under test. This is the design under test. So what I'm trying to do, I write another set of program instead of simply writing a test bench, which generates the instruction as per my instructions and sending the signals. Just because it is full adder having limited number of signals, I write a program 1 or 2 cases and force the input, and I observe the results, right? But you think about a processor. For processor, different operations are there: addition, subtraction, multiplication, division, logical AND, logical OR, and so on. Different operations are there. I want to check any of the operations randomly by applying some new set of inputs, and I need not say that this is my expected results. So what do? For that, I have another unit called golden unit. That's called golden unit. Okay, please pay attention to this. If at all any questions, please feel free to ask. The scoreboard contains this golden unit. Okay, what we have done with the earlier test bench with AND gate, what we have done in AND gate, we have forced only the input. The input goes to our design unit, it produces the result. How do we verify it works properly? Manually. We see the log report. For 0, 0 input, it gives 0. Okay. Are we observing through our eyes or not? Someone please say, respond. Are we observing through eyes or not? Every input combination we have to see 0, 0, 0, 0, 1, 1, 0. All these things we have seen. But there is another simple and interesting way of doing it called equivalence checking. Equivalence checking means you design a system and you try to design another simplest and verified version of the same. You apply the input pattern for your new design, and the same inputs you apply for our golden unit also, forcing the inputs for our golden unit as well as design under test. You compare the results generated from the design under test as well as from the golden unit, and we ensure that both are working equally. That means producing the same results under same input combinations. If at all any difference, we have to mark the differences and we try to mark the differences and try to rectify the problem in our design. Is the idea clear? This is called equivalence checking. Let me come back again. So here is my design under test. Here is my an environment. The purpose of environment is to generate the input patterns. Once it generates, that must be given to a driver. The driver drives the input to design under test. The response from the design under test will be given to a monitor. Monitor takes two things. One is output response from the design under test, and what kind of input is applied to design under test from the driver. Is the idea clear? I take the input, what is applied, what kind of response produced, both into the monitor. I inform these things to the scoreboard. This is the input applied. For this input, the DUT has produced so and so result. If I inform to the scoreboard actually internally having a golden unit. A golden unit. That means a pre-verified unit, functionally an equivalent unit. Okay. So this golden unit also applied with the same input, and it is also producing the results. Now I compare the results from the design under test and the golden unit, and the scoreboard will tell me whether both results matches or not. End of the day, what is the benefit here, sir? The benefit here is that we need not manually look for every input combination. It is the responsibility of the scoreboard to compare different input combinations applied. And the corresponding results from design under test and the golden unit, and it will tell you as a report all combinations were matched, or for so and so combination there is a mismatch. It will inform you. Is the idea clear, sir, or any question? This is the broad picture behind this test bench architecture of system Verilog. Any general questions here, please? Make it fast. Please do it fast. Any questions? The broad picture of architecture, test bench architecture. Am I audible or not? Any problem with my voice? Am I audible?
All good, sir.
Any questions? Please post some questions. You should ask. There are many modules here. You should ask 1 or 2 questions there.
Yes, sir. Then what is the purpose of interface?
Interface. Okay, madam. Okay, I'll come the modules one by one. Any questions from students? I'll come here. Okay, interface I'll discuss. Anything else? Rajeshwari, Aravind, 93 members are there almost.
The golden unit you were telling, right? What exactly was that?
Okay, let's say golden unit means suppose you assume that it is an adder circuit you have implemented in the design under test at the gate level. In the golden unit, we may be implementing as a simplified version, maybe a data flow modeling or behavioral modeling. Okay, in a simplest form. And we verified that model
instance,
already.
An
It's
instance.
equivalent, same adder, but representation will be different.
Instance.
It may not be the same code. Please understand this. Is the idea clear?
Okay.
It is something like a part model or a pattern. You check a pattern, verify, and keep it aside.
Okay,
you
got
go
it,
for a
sir.
new pattern, and that also must perform the same functionality. Okay. If there is a mismatch between the two means, then we should say that. Shall I say in Tamil? Will you all follow Tamil?
Some
Yes, sir.
Kerala people
also there.
are
Okay, let me
yes,
go
sir.
with a simple example here. Oil container. You purchase oil from a supermarket. You go and see from different companies. They come with different shapes of bottle, right? Some with a handle, some with a different kind of structures, a mug pattern, a bucket pattern. All finally should have the hold same amount of quantity, right? The shape, even though if it goes in difference with the different handles and all, end of the day, it's going to hold some quantity, and that should be almost equal, right? We try to verify it. Does it matches? This is 200 ml bottle. This is another 200 ml bottle. Does it really suits into that, right? The pattern may be different. In that way, you please think this is also adder, and design under test means this is also another adder. If 4-bit adder, this is also 4-bit adder. Is the idea clear? But representation is different, and it is already verified one. That's called golden unit. Nothing beyond that. Okay. Anything else?
Yes, sir. Actually.
Any other questions, students, please?
Yes, sir. That mailbox and handle.
Okay. Mailbox and handle. We will come to that. One by one, I'll come. During that time, definitely we are going to discuss here. I'll come to here. The first thing. What is the purpose of generator? The fundamental unit here. The purpose of generator. Generator is nothing but a random number generator. Why there is a need for random number generator is the first question. Sir, let me give you a 32-bit adder. Okay. If I say 32-bit processor means it can perform 32-bit addition. Am I right or not? A 32-bit ALU or 32-bit processor can perform 32-bit addition, isn't it? In such a case, what may be the total possible input combinations? How many possible input combinations are there? 2 power 65. Why? Sir, if it is a 2-bit adder, how many combinations are possible? 2-bit adder.
4.
Okay, A is a 2-bit number, B another 2-bit number. When A and B, when I apply, when A is 0, 0, B may be 0, 0 or 0, 1 or 1, 0 or 1, 1. Similarly, when A goes to 0, 1, B may be 0, 0, 0, 1, 1, 0, 1, 1, right? So, A itself having 2 power 2 combination, B itself having 2 power 2 combination. So, the total possible combinations are 2 power 4. In addition to that, when you check an adder, there is a carry bit, right? Full adder, if I take, means one more carry input comes. Right? The carry may be 0 and some situations it may be 1. This gives another 2 possible combinations. So 2 power 5 combinations are there in case of a simple 2-bit adder. So how many input combinations are there? Can you guess? 2 power 5 means? 2 power 5 means how much it is? 2 into 2 into
32.
2. Yes, thank you. 32 possible combinations are there. Sir, I am speaking about 32-bit adder. That means A, a 32-bit number, B, another 32-bit number. Adding the 2 along with the carry. So, A itself having 2 power 32 combinations. B, another input, 2 power 32 combination. How much it is totally? 2 power 64 combinations. Under all these situations, for some certain situation, keep carry input as 0. In all other situations, keep carry input as 1. So, that gives another 2 combinations. So, totally 2 power 65 combinations are there. Do you agree with this or not? Anybody having questions?
So can you explain again, sir?
Okay, I'll come to this. 2 power 32 combinations are there for input A. Do you understand this? Sir, A is a 32-bit number, sir. What are the possible values of A? How many possible combinations of A? 32 zeros, maybe 31 zeros followed by 1, right? If you consider 2 power 32 combinations are coming or not, just before you said, right? If it is a 2-bit means how many combinations are there?
4.
0, 0, 0, 1. Yes, it is 2 power 2, right? Is it 2 power 2 or not?
Right.
So if it is a 32-bit number, won't it have 2 power 32 combinations?
Yes.
Okay, let me take another input, B. B, how many possible combinations are there? That is
32.
another 32-bit number. Sir, I speak about 32-bit adder, 2 numbers, 32-bit number. And one important for you, one important question to you all. Sir, I am using my laptop for presenting you with Core i5 or i3. You know what is the size of this processor? Size in the sense not physical dimension. I mean to say the operating capability. It's a 64-bit processor. How many bit? 64-bit processor. I speak about, after all, a 10-year-old processor, a 32-bit processor. I speak about a Pentium processor, the first 32-bit processor. 586. 586 is a first 32-bit processor called Pentium later. Okay. So 2 power 32 for B, 2 power 32 for A. When A is at one particular value, B can have 2 power 32 combinations. When A can have 2 power 32 combinations, B with another 2 power 32 combination, how many possible combinations are there with respect to A and B alone? 2 power 64 combinations we need to apply. You want to test the adder. A 32-bit adder means you are supposed to apply 2 power 64 combinations of input one after the other. Assume that one more carry is added. Adder means 2 A and B input, one more carry input, right? Carry is a single bit, right? Single bit means it can have 2 power 1 possible combinations. 2 power 1 means 2 combinations, either 0, for sometimes it is 1. So totally, if I multiply this also, it will become 2 power what? 65. Sir, you should have this question in your mind. Why it is a random number generator, sir? Why not like a counter generating the sequence from 0 to all possible values one after the other and applying and verifying? I'll give you the reason now. 2 power 65, right? Sir, any questions or doubts in this? 2 power 65?
No, sir.
Okay. Now I ask you to say, I say that I am applying one input, taking the response in nanoseconds. How much it is? In 1 nanosecond, I apply one input pattern and I verify the result. I want to apply in sequence one after the other. 2 power 65 combinations. How much time it will take? Please tell me. 2 power instead of 2 power 65, 2 power 10 means 1000, right? 2 power 10 means 1000, 1024 actually. I just take for simplification, it is 1000. 2 power 10 means I say 1000, actually it is 1024. So it is 2 power 10 into 2 power 10 into 2 power 10, like how many? 60 means 2 power 10 6 times. So 2 power 10 3 times you take. How much it will be? 10 power 3 into 10 power 3 into 10 power 3. 10 to the power 9. Your nanoseconds will go. It will come in terms of seconds. For applying 2 power 30 combinations, it takes 1 second approximately. Multiplying by 1000, 1 second will become 1000 seconds. Again multiplying by 10, 1000 seconds will become 1 million seconds. So if at all you calculate in terms of days and year, it will approximately take, I just tell you, 100 or thousands of years. It is actually more than that. I'm not going for calculation. It will take some number of years to complete verifying 132-bit adder. 132-bit adder, you cannot verify exhaustively, giving all possible input combinations. Is the idea clear for everyone?
Yes, sir.
That is the reason I don't apply all possible input combinations, sir. What I normally practice here is that I'm generating some random numbers and applying. If I say I apply only first set of inputs, you will say why not second. If I say second set of inputs, you will say why not the first set of inputs. Because you are not going to verify this within the specified time. The product will not come into the market even after 100 or 1000 years. Just for verification stage itself, it will go. For that, what I do, I generate only random number of inputs and I verify for those cases and I satisfy with only verifying for those input combinations. Is the idea clear? Or any questions? This is what basically a generator is, a random number generator. Whatever the input you want to apply, it has to generate some set of combinations randomly. And I cannot apply the generated input to my design under test because the design under test may have other tasks or different complex units of operations. So the moment I generate and I apply to the design under test means there will be race conditions. Race conditions means which input goes first, which input goes later due to some connectivity issues and all. Synchronization problems will come. Okay, so normally what I do, once I generate some pattern, I put it into a storage place called mailbox. That is where the point comes called mailbox. What you say it is transaction, basically transaction actually you should see as a 3 different aspects. Transaction must be viewed as a 3 different aspects. One is the data. Transaction is nothing but basically a data. I am generating random number, nothing but a data. I am trying to force into my design. Okay, so that is nothing but my data. The data I don't apply immediately. I use a mechanism called mailbox. This is my mechanism. Okay, mechanism means I store the randomly generated value into the mailbox one after the other. Whenever the driver understands that the design under test is now free to apply the next input, then it will read from the mailbox. It will read from the mailbox and force the value into design under test. Is the point clear? Or any questions? Anybody having questions here? So you should observe this as a data. Some data is being generated and passing, and you should observe this as a storage element called mailbox. So I store the input. Whenever driver think that the design under test is ready, it will take the next input and apply in sequence without any consequences or race conditions or timing issues. Any questions, sir? What is the third aspect, sir? The third aspect come here is that this particular block, transaction block, sometimes passing the input in this direction, sometimes passing the signals in the other directions, right? So this data I am going to send. I am using mailbox mechanism to store, then retrieve. Whoever needs it, they will retrieve. And also I say that as a transaction in the sense, it is something like data is being passed either from one direction to other direction or in the opposite. Okay, we send the data, we specify the direction, we store the value and access. without any consequences through a mechanism called mailbox. Okay, so driver is the one who is going to force the value, whereas the driver will not generate the actual input. It is generated by generator. Is the point clear or any questions? Under this only semaphores coming, sir. Mailbox, semaphore, all these things are in this transaction mechanism only. Here also we are communicating, right? So without any consequence, we put the data, somebody will access it without any consequence. Any questions?
Clear, sir.
Okay, I'll come back to the next one, right? Once, sir, feel free to ask. Nothing is a hard question or tough question. Okay, all you ask is the one supposed to be discussed. You think in that way, and you ask your questions, whichever comes into your mind. Okay, now what I do, I generated some random numbers. I put it into a storage place called mailbox. What I store means it is my data, and it is being called in the name of a transaction, like data one after the other it goes. We say that money transaction. Money is nothing but the data. Basically, if you see as an individual unit, and the instance you make it giving some new set of values means it is called a transaction. And the mechanism we use is called mailbox. It goes to the driver. The driver reads from the mailbox whenever necessary. Force it into design under test. The design under test all response, the value will be given to a monitor. So monitor performs two things, sir. One is it is observing what kind of input forced, and it is observing what is the result from the design under test. Both the things it has to monitor. Okay, so it takes signals from driver as well as design under test. Now what the monitor will do, it is capturing some value and it is putting into again another mailbox here, because the scoreboard is the one. Once if I put some input combination and output, the scoreboard will take this. Under this I have my golden unit. As I said before, this is my golden unit or a verified unit, represented in a different form, that's all, in a simplest way, but it is verified. I supposed to compare, so I take the input and apply here, and it will compare, it produces some results, and compare with the results from the monitor, and it will say it matches. If there is any mismatch, it will say there is a mismatch in the particular input combination. Okay, so because it is executing very similar to your design under test, because we are forcing the value and getting the response, for here I should not go with any race conditions. I should not force the value immediately. So I provide a mailbox here also. After all, I'll tell a mail has come to you. Whenever you are free, you open and see, read it, you understand it. That's all. Any questions, sir, about this, the whole structure? Sir, as I outlined in the previous slide itself, this is called equivalence checking. Equivalence checking means you keep your design, maybe represented in different style, right, as per your need. And there is a golden unit which is represented in another style. That's all. It is also producing some results. I compare. When there is a match between the two for the same input combination, I say that no error for this input condition. And that is also a waste of time. I should not display the good results, right? Only if there are some exceptions or change in result happens, I should intimate. I'll see that, okay, this particular input combination does not match. So where the error could be in my design. I just want to concentrate only on this. This is the key role of my scoreboard. Any questions?
Sir,
Yes.
sir, we design under test, we can write any kind of program, any number of size, whatever it is up to the user. But
Yes.
how can for all the program, the scoreboard, the pre-designed one, it is available, sir, in scoreboard? How it is taking any program it will be?
Madam, it's a good question, madam. Basically, any kind of design you write means, if it is a new input, assume that this is the first time design. Okay?
Yes.
The
Okay.
functionality which never ever before appeared means, assume that
Okay.
this is the first time means, then you cannot have a golden unit for that. You
Okay.
may have a lookup table option. Lookup table option. Lookup table means when this comes, what should be the corresponding results? I don't do any calculations and all. I can have simple lookup table. For
Okay.
example, in our 10th standard, we do right 5 5 25 like that. So like that, I can store some table. I will simply compare with the results in the table. I can show the results. That's all.
Okay.
Is the idea clear, madam? I need not have any architecture to represent it. If at all
Okay.
design available and you want to improve it, and there you wanted to see that almost the functionality matches, but this time it's an improved one, means you may go for what I said called golden unit, madam. Is the idea clear, madam?
Yes, sir. So for all design, so new design means what, sir? So you are
Equivalence.
telling if it is any new thing newly, if you have to write the golden equations, golden thing, it's not available like that.
In the
So
sense, you
that
can
is
have
predefined.
test by, you can have lookup table, madam. Lookup table.
Okay.
In microprocessor programming, you might have studied about lookup table, madam. So just
Yes.
if you I ask you to calculate square of some number or cube of a number, means instead of wasting our time, what we can do, because it's a random event, I can store for 1 means 1 cube 1, for 2 means 2 cube 8. Like that I can store in a memory. Instead of developing it, I will just refer to the table. Does the value match or not? So there is no hardware or design aspects involved in this. You can go for lookup table approach also.
Lookup table approach, when we have design it, based on the design, it generate a lookup table, or already it is predefined in the scoreboard?
No. Lookup table, you are the one supposed to prepare.
Okay, based on design.
Madam, if you are designing a divider, means what is the aim? It has to divide some two numbers. You want to verify,
Yes.
means you should know the result of the operation, right? What you are expecting. After all,
Yes.
machine can't do anything, because what it's supposed to do, we only instruct.
Okay.
When it gives the result, means the expected result we should be known in advance, and so that we can go for equivalence checking. Else, as you said, you may think about artificial intelligence or new kind of thing, where the result can be something different from the existing one. In such a case, it will say how much is the error and modifying the design and all will be there. Is that okay, madam?
Okay, sir. So suppose we are designing a divider, for this they created a lookup table kind of things.
Yes.
Then it verify from the actual design.
Yes, madam. You have two options,
Okay.
madam. One is lookup table, madam. The other option is equivalent hardware, madam. If it is an
Okay, sir.
equivalent hardware, I call it as golden unit.
Okay.
It is
Okay.
lookup table means, as I said, it's like a table we refer to, just comparison. I store all possible input and output combinations. You might have done some project in image processing, right? In image processing, if it is a defective one or a good one, Apple, you want to detect, means you store some samples, right? We just take
So
and
instantly it will create based on the design.
Yes, madam. Exactly.
Okay. Thank you, sir.
Thank you, madam. So either lookup table or golden unit approach, both way possible. Okay. Golden unit or lookup table.
Okay.
I'll go with that. Okay, this is the generator. So generator generate random number, then followed by interface. The interface contains design signals. So this is the question asked by madam, sir. What is this one? Interface. Why there is a need for interface? Actually, if you consider the modern day processors like Core i3, Core i5 and all, there are 1,000 pins. 1,000 pins, around 1,000 pins. Even more than that. In a chip, we have this many number of pins. Assume that 10% is given for only supply. Maybe 5% you allocate. Remaining 900 pins will be there only for I/O, input and output. So what I do, I just list out the signals as a separate program. That is called interface. Interface is nothing but encapsulation of input and output signals, under which I can say that what are the signals are input, what are the signals must act as output. The beauty of interface is that when it receives input from the driver, it receives the input and sends here. Okay, some signals will be acting as input, some signals will be acting as output for the design under test. When it comes from design under test, some of the signals will be acting as input this time, some will be acting as output this time, right? So with respect to perspective, the direction of the signal will change. For example, A and B are the input for an adder unit. Let me say A and B are the input for an adder unit. It performs some AND operation. What is the output here? Y. Can you please guess? Is Y is the output for test bench program? Suppose I want to go for equivalence checking. I want to see the results. Now Y becomes the input for this module, right? Y is an output with respect to design unit, whereas the same Y act as this is an input. an output from AND gate, but it is an input for another module, right? So signals also in this way sometimes act as input, sometimes act as output. Means interface combines the signal and written as a one single file. It's like a block. Under this block, you can instantiate any number of times. How we instantiate modules? Like adder may be instantiated many number of times to go for parallel adder, right? In the same way, interface block also can be instantiated any number of times. In every instance, you can define the direction. Sometimes the same signal act as input. The other situations are instances, it may act as output. But the instances are different. Is the idea clear? So when there are large number of signals in a design, instead of going with calling the signal name every time, you just put it as a one single program and call it into your wherever it is necessary. Driver needs signals of design under test. Monitor needs signals of design under test. Excuse me. 1 minute. Any questions? Any questions, please? So the same port acting as input with respect to driver. The same set of ports acting as output with respect to monitor. So I write the interface as a separate program or a block. So that I can instantiate it with respect to driver. The same may be instantiated with respect to monitor, like wherever it is necessary. Any questions about this? I think it may not be much easy to observe through theoretical way, I believe. Is the point okay, madam? Parvata madam, shall I go into the execution part?
Yes, sir. The architecture we got clear idea, sir.
Okay, madam. So I'll just finish it up for this one just by reading the lines. So you can just while going through the slides, please ask these questions. First one, generator generates random inputs or random signals instead of going with all possible combinations. Interface is the one. It contains all the signals involved in your design as a separate program block. Okay, so it can be instantiated for different situations for different purpose. Next one, driver, which drives the generated signal from this into the design under test. Monitor, which takes design input output ports. So input for the design unit, output from the design unit, both will be monitored to capture the design activity of your design. Next is scoreboard. The scoreboard checks the output from the design with the expected behavior. Please understand that expected behavior means behavior expected is represented either as a golden unit or as a lookup table called the LUT. If we can understand the FPGA based approach, lookup table approach means it is easy for us to understand this. Next one, environment. Environment is the one which contains all the testing related modules. All the testing related modules like your generator, driver, monitor, scoreboard. Sir, why there is a need for saying this environment again? Environment may be tested for different conditions. Same DUT may be tested by environment E1, environment E2. Environment E1 will have set of conditions. Environment E2 may have other set of conditions, right? You can create different environments for the same design unit and you can verify it, right? So it's like you have the option to copying again. Environment is nothing but again another encapsulation. That's the reason we think about object-oriented programming here. Environment is nothing but a class, right? It's a class. You can instantiate it any number of times for different purposes. The next one, if you come here, test. Test means including multiple test environment. Including multiple test environment. All testing units together is called, one single block is called test. Generally, we go for single test environment. If at all necessary, you can go for multiple test environment. Putting all together comes into testing unit or test module. Your design is separate, interface is separate. Keeping all these things under one roof is called test bench top. Is it clear? It's a top level module which contains test components and the design under test. including this interface. So the environment can be changed, fine adjusted for different configuration settings. You test for this case. I say one environment to test for arithmetic operations. The other environment may be testing for logical operations. So the other environment may be string operations. Right? You can create different environments, multiple testing environments. Okay, enable one at a time, compare with the scoreboard and see. Okay, so let me go with the programming aspect. Come back here. First, let me go with the fork and join. Or shall I go for full adder, madam? The complete test architecture, or shall I go as per the second unit?
Sir, as per the second unit, sir.
As per second unit. Okay, madam. I'll go with the first one, fork join. I'll go with fork and join. Dear students, I share the link for you. Please make use of this. Okay. There are many ways. Have you all opened this? Fork and join. Here is the keyword in this program, fork. Here is the program called join. It's a test bench program where I want to test, design under test for containing different processes. Okay, process also called as thread. Please understand this. So what is the purpose of this fork and join? The alternate for fork and join is initial and always. Initial and always means initial block. If I say how it will work, it will execute the statement one after the other. Okay, all the statements executed sequentially. When I say initial, and it is one-time execution, initial block, one-time execution. Whereas this always block, multiple times execution. Some condition we execute it any number of times. That is always block. These are sequential in nature. The purpose of fork and join is that executing multiple processes simultaneously. Multiple processes or threads simultaneously. You know what is process? Somebody please tell me what is process? Process means a program under execution. That's all. Program under execution becomes process. The process is also called as a thread. So we are not going to take up any real-time process or thread. Instead, I am just considering that one particular operation I am doing. I just display thread 1 finished. Okay, because I treat this as my thread 1. I say another operation under this thread 2. Okay, and it is inside it is having sequential in nature. Sequential in nature means because I have mentioned begin and end, whatever the statements mentioned within this begin and end will be executing one after the other. So first the statement will execute, after this 10 units of time the next statement will execute. So this is thread number 1, this is thread number 2, thread number 3 is there. Okay, I have mentioned with the keyword fork and join. All these threads are clubbed together with the help of fork and join key. Is that clear? Before I enter into this block, I write a statement. Okay, I am in the main thread. Okay, out of this fork and join is called main thread or parent thread. Please understand this. This is main thread or parent thread which is written outside this fork and join. So this is also part of the parent thread only, main thread. So fork and join has been finished. Is the idea clear, sir? I'm taking some number of threads. I'm combining with the help of fork and join. I'm trying to execute it. Shall I run this program now? Are any questions here? Please ask. Any questions with respect to this program? Some of the students, enthusiastic students are here. Please ask your questions. Feel free to ask. Thread means a small piece of a process. Please understand. Again, it is an independent unit. It doesn't depend on others. It can execute on its own time. That's called, when it is an independent unit means it becomes called process or thread. Thread means a sub part of a process. Okay, smaller than a process is called a thread. So I have some number of threads and 3 threads. In addition to that, the main thread is available, which is out of fork and join. Okay, sir. Shall I run this program? So the matter of discussion here is, pay attention to this, how it executes. First, I have my main thread. Okay, so the program starts from here, comes to the main thread. Whenever it sees, because there is no delay mentioned here, it directly comes to here. So the main thread fork join is going to start. Okay, is going to start. Fork join is about to start. Now, once I enter here, you look at all these are independent. What are the things are independent? My thread 1, thread 2, and thread 3. When the thread 1 starts after 30 units of time, while thread 2 starts after 5 units of time. Thread 3 starts at 20 units of time. So who is first? Can you guess? Among the 3, I just trigger all 3 simultaneously. I give the option. Whoever interested can go first. Which one will go execute first? Thread 1 or thread 2 or thread 3?
Thread 2.
Thread 2 will go execution first because all are running parallel. Thread 1 or thread 2 or thread 3. Minimum delay starts with the thread 2 only. Thread 2 having 5 units of delay. So as you can observe, thread 2 comes here at 5th unit. Okay. Again after 5, you add 10 units of delay because it is sequential execution, right? 5 plus 10 how much? 15. So at the 15th time, thread 2 has finished. What about this one? Among the two, it is waiting for 30th unit, it is for 20th unit. So thread 3 is ready at 20th unit itself. So already we waited for 5. 5 plus 10, 15. 15 is over. Then immediately at the 20th unit of time, thread 3 will start. Please here, thread 3 will finish. It is waiting for 30. So at 30th time, thread 1 will be finished. Is the idea clear? And finally, it says that main thread fork join has finished. Sir, what is the importance of this fork and join? When there are multiple processes to be verified in your system, you are just specifying the timing of their activity. One must be executed first, the result may be copied into others, or the second module may be taking the input prior to the first one, so you have to execute first, right? This is where the fork and join comes into picture. Whenever you want to verify any complex system with multiple processes, how you are going to verify the functionality at different times. Okay, the fork and join will help you to execute different processes simultaneously, but under that you can specify some delay as per your needs and you can change the order of execution. Okay, shall I go for the next one? This is about fork and join. So it may not be interesting without discussing. Sir, did I share the link for this? Did I share the link?
Yes, sir, you have shared.
Okay, then I will go for this.
Sir, without giving that delay, then what will happen, sir?
Which delay, madam?
Everyone, sir, as 30, 5, 10, 20.
Very interesting question, madam. Very, very interesting question. Everybody should make a note of this. If I do not specify any delay, all will be updated in the 0th time itself. All will be executing in the 0th time itself. All will be executed simultaneously. Let me just remove this delay, madam, for your information. I just remove this. Okay, no time updations will be there. No time updations. Madam, can you see this?
Yes, sir.
What is the beauty of this? Is it possible for doing all operations at 0th time? Not at all possible. In real time, it is not possible. When you enter into a process, it may take some amount of time, right? Then the other one may be starting. But here, when I say 0th time means, please understand, I'll just go with the paint. I'll go with the paint because it's a critical thing to understand. You should understand this. This is how we apply the system, right? In our computing systems, we apply the clock signal. We go for process 1, process 2, process 3. 1, 2, and 3. Instead of giving delay, if you say that you are executing multiple processes means before arrival of the next clock pulse itself, all these events, all these processes will be finished. So I claim that this is my 0th time. The moment next pulse comes, all will be completed its previous execution and waiting for applying the next pattern. Once again, the calculations will be carried out and the result will be performed. Is the idea clear, madam? It's a way of the machine understand the situation. 0th time means it is not all doing at 0 itself, like 0.001, 0.002, right? It is
Okay,
not
sir.
good to elaborate all these things. They simply say that it is 0. All are being executed in 0. So if I say 5 units means and the next pulse, or maybe after 5 units of time, these are all happening. Okay, without specifying the delay, you should understand that all executing at the same time. That's all. I mean at the 0th instant. Now let me take you to the next one because at least we can go with the fork join clearly. So I'll take you to the variations in fork and join so that we better understand fork join by any. These are also options. These are also options. Very similar to the previous one, right? This is another program. I just have my test bench and I consider this as the whole lot of process with the initial keyword and begin. All these things are taken as a single block with the end. Inside that block, I have some main thread and fork and join. Instead of saying join, I say join underscore any. Okay. So what is mean by this join underscore any? Instead of join, if I give join underscore any, what will happen? Let me run this program and show you the results. Okay. Please look at here. The very first statement itself having the delay. So at 1 nanoseconds only the execution starts, the work start. I mean, the fork join block is going to above start. Okay. Under that I have different threads. After 5 units, thread 1 starts. After 2 units, thread 2 starts. Inside I have 2 operations. So after 2 units, after 4 units, then another thread with the 10 units. If I say join any means, instead of join, if I say join any means, join normally the statement, this is if I mention some statement, right? After join any, please look at here. There is a statement which is out of the fork join, right? This will be executed only after completion. Normally, only after completion of all the threads inside the fork join, this execution will begin. Suppose I am not interested with that. I just want to go for this one. After completion of any of these threads, any one of the threads inside this fork and join means I have to go for join. I'm sorry. Join none means now I don't wait for any of this. I can simply go for this. Please wait. It is not join any. So I'm sorry. I'm using join any. Join any means any one of the threads inside. So let me run this. Please look at here. I am using join any. Join any means inside fork and join, at least one thread must be finished. So which thread will be finished earlier? Can somebody please guess and tell me which thread will be finished earlier?
Thread 2.
Yes?
Thread 2, sir.
Set 2 may not be. I'm sorry, the reason is it
Ah,
starts
total
at
6
time
unit. Okay, 12 to 1.
exactly.
Okay.
Exactly. So we start with a delay of 1 plus 2,
Okay.
3. Again, 3 plus 4, 7 units it completes. Whereas the first
Okay.
one having only one single statement under
6 unit.
this, 1 plus 5, 6. At 6th unit itself, thread 1 completes. Okay. And as you said, it is 7th it completes. After 10th unit only, it will go to its execution and completes, because it is having one single statement. Now I'll come to here. What is the purpose of this join any? Join any means any one of the threads should complete, right? Which thread is supposed to complete? Which thread completes earlier? Under this case, once I started, thread 2 has started. Okay, after 2 units. Adding 2 with that 6, at 6th unit, what happens? Thread 1 itself completed. Because thread 1 itself completed, thread 2 is not completed. Any one of the thread complete means what happens? You are coming out of the fork join. So we are coming out of the fork join means we are coming to the parent one. The parent thread. This is nothing but the parent thread. Inside the parent thread, we have the child thread. Some number of child threads. Okay, thread 1, thread 2, thread 3 are child threads. I don't wait for the execution of child threads. So only one I wait. So thread, of course, thread 1 has thread 2 has started early, but it is not completed. While thread 1 has started but completed. So what I do? I start to execute my parent thread. Once parent thread is executed, what we do? Then we go for thread 2, but not anymore means actually I have stated here this statement, right? Thread 2, but not anymore. So that means thread 2 has finished. Then comes the thread 3 after 11 nanoseconds. Is the idea clear? You want to verify certain system, inside some processes are verifying it. I want to execute my master thread after completion of any one of the child thread means I go for join any. So any one of the child thread completes means the execution will begin in parallel with respect to master thread also will begin its execution. No, sir. I don't want to wait for execution of any child threads. I simply want to go for executing child thread. If at all necessary, parent thread also to be executed means go for join none. Okay, go for join none. Save this. I'm trying to go for join none. I run this program. చెప్పింది చేశాను థ్యాంక్స్ మైండ్ ఎక్కడ ఉంది టైప్ ఇది ఒక్క హెల్ప్ వెళ్ళిపో కరెక్టెడ్ హలో
Yes, sir.
shall I run this one join none? So the parent thread will not wait for execution of or completion of any of the child thread. Please look at the results here. After 1 nanoseconds of delay, I start the fork. What happens? Within 1 nanoseconds itself, I am going out of the fork join. Why? After fork join, okay, my parent thread itself having another process to carry out. So the execution goes to parent thread immediately after fork join. Only after this 2 units may start, the 5 unit may start, this may start, this may start, right? This is called fork none. This is called fork none. Fork none means the parent thread will not wait for the completion of child thread. So it will directly start. Any questions here? Madam, any one of the, I think a fork and join we have done with. Let us go with one more example. I have many. I'll just show you the list of contents here. If at all you ask me, I'll go for selectively that particular module. Please see through this, madam. We have interface, we have mailbox, we have semaphores, we have constructor, event triggering, always flip-flop, always latch, always combinational. Which one shall we take, students? We have limited time. If you ask me any specific topic from this, I'll go for an example. Please look at here. Let us go into the syllabus first. Let's go into the syllabus. So out of this, you want to go for functions, task, fork join already I have done with examples. If you ask me any one of these, functions or task, void functions, argument is nothing but how we pass argument to functions. Argument may be passed by value or passed by reference, right? So all these are related to functions only. And the second one, you may ask me to go for semaphores or mailboxes, even events also. So whichever example you need, I will go into that. This is about inter-process communication. The third one is all about the interface. Bundles, smart boards, clocking blocks, all these things. Which one do you want me to go? Choice is yours, please. We will have a time in future. It's not an issue. I'll share. The link is available with you, right? If you
Sir,
want.
shall we go with that unit 2 interface constructs?
Interface constructs.
And that part, sir.
Under that part, we want to see. Okay, na, madam? Interface.
Yes, sir.
Okay, madam. We'll move on to that. So, with respect to interface, one program which combines most of the concepts related to all this interface. I'll share the link. Students also can simultaneously. This is about interface. Come back to here. So first let me start from the DUT, some modules. Okay. What I have taken means, this is my, actually everything supposed to be written as test bench only. I am just calling it as my design under test. Okay. What do? I just call with module and end module. I am passing my bus as an input for this, okay, into my design. This is nothing but attaching an interface. So it is better to start from here. Interface must start with the keyword interface and terminate with the end interface. Did I say the purpose of interface? What is the need for interface? What is the purpose of interface? Somebody please unmute and answer. Purpose of interface? Somebody. Whichever signals related to your design under test will be specified under a single module called interface. So in my design, in my module, I have signals called data and enable. These are the signals. Is the idea clear? Or ports. So that I declare in a separate block. So instead of specifying these signals anymore, I will simply say that name of this, my bus. Is the idea clear? And its instance name, I just assign one instance name called bus if. So hereafter, I am referring to all the signals referred here. What are the signals, sir? No? Excuse me. So what are the signals specified inside this interface? One is data input, which is of size 8 bits. Normally we call it as vector input. Another input is enable. Is the idea clear? So I am specifying list of signals involved in my module. And I am specifying the direction, which one to be input, which one to be output. With respect to my test bench, data acts as an input. Clock and output, I mean data and clock are the inputs and enable is my output with respect to test bench. So whenever I am using the same my bus, that means interface, inside the test bench, it will be acting like data and clock will be acting as input, output enable will be acting as output. Whereas if I go for my design under test, under DUT, I am specifying the direction as data is my output, data enable and clock are the inputs. Okay, so in this way I just specify. Is the idea clear? So I can specify the directions with respect to my test design under test bench, with respect to test bench on the left side, or with respect to design under test on the top. So I don't declare any ports here. Have you seen this? Normally we specify ports, right? A, B, Y and all. That and all declared inside the interface. That's all. So this simplifies. Once if I list out the ports and its direction inside an interface, instead of listing the ports here, I'll just call the name of the interface with its instance name. Then how do I access those signals? Suppose I want to access enable signal, means I should use the instance name with the dot operator, enable, dot operator followed by enable. Is the idea clear? How do I access the clock signal? With the name of the instance. Basif is the object, right? I'm creating an object. With the dot operator, I am accessing clock. With the dot operator, I am accessing enable. With the dot operator, I am assigning some value for the data. This is nothing but an increment operation. Is the idea clear, sir? Any doubts? If the enable input is not activated, means data will be 0. Any questions or doubts here? Students, any one of you, please ask any questions from here. Do you understand the difference?
Sir, in this design in top module, no need to write any inputs and outputs, sir. Directly.
Exactly, madam. Exactly, madam. This is what the purpose of interface, madam. Whatever ports you want to use it in your module may be declared as a separate program, madam. A block called interface.
Okay.
Once
in
you
design
declare
unit.
the signals inside, once you declare signals inside, you can simply specify, refer to this, that's all. Interface, and its name is my bus. You call by its name, that's all. So these are the list of ports. And what is the purpose of mod port, sir? Mod port means you are specifying the port direction. So data and clock are the input, enable is my output. You are specifying it. Okay. So I am using the instance name for this one. For this is for the purpose of DUT, this is for the purpose of test bench. Luckily, I may be using in the same way, right? Here also output. Your output is enable. Your output is data. Your input is data. Your input is enable. Is the idea clear,
Sir,
madam?
can you please can you match with the architecture, sir, which is going input output for this?
Okay, madam. Why
In
not?
architecture.
1 minute, madam. Interface. Please understand here. This is my interface. I'm sorry. This is my interface. Okay. Here I declare some signal like enable,
Data.
clock, data. Okay, madam.
Yes, sir.
My design unit DUT. Please look at the reference here. Please look at the reference here. In DUT, what I say? Data is my output. Enable and clock are the input. So assuming that this is something like a counter, I'm applying a clock signal and enable. Okay, enable. When I apply this clock and enable, it simply counts and produces the data. Every time it's incrementing its value. This is the functionality of this DUT. How do I verify my DUT? How do I verify my DUT? So this I should read. This I should read. This is my test bench, right? Test bench. I mean to say, this is my test bench, like a top block. This is my top block. Block. For me, I am observing this value. I am observing this value. So for me, this is my top block, right? Test bench unit. Because I am observing, I am taking this as my input. Because I want to force the value for my DUT, this clock and the enable is acting like an output from me. Who is forcing the value? Test bench. Who is observing the value? Test bench. Because it is a container which has your design unit inside. Okay, na, madam? So with respect to test bench, my clock and the enable are the outputs. Data is my input. Is the question clear, madam?
Yes, sir.
Please look at here. Data is my input. And clock supposed to be generated inside. So maybe clock also may be generated, taking this as an input. So I generate. Okay. So I am generating this enable from my test bench. Actually, clock also I am generating because it is not coming out of this DUT, right? It is actually a separate module. Clock is a separate module which is supposed to be input for the DUT, and the same is being generated for test bench also. Okay, so it is not, it is both, in both the aspects it is common. Clock is input in both the cases. Only thing is output enable signal is generated by the test bench while taking output from the design unit as a point of observation. I am taking this as an input. Okay, is the idea clear, madam?
Yes, sir.
Module, test bench, module, design under test. You see here, now also I am saying module, top level block, test bench. Here locally I am generating some signal. Under this I am creating the clock. So clock is not specified inside our design, not in the interface. It should be specified only in the test bench. Okay, I am generating the clock. So what do I do here? I am calling this my bus, and this time with an instance name of busIf, and I am passing the signal, what the argument I have generated here, clock, as one of the variables here. I am passing this. So I am instantiating the DUT under this top level block with an instance name of DUT0. Can you see this, madam? The DUT module I am instantiating here. Instantiating the module, generating the clock. Okay, in the bus, I mean to say. For the interface, I am passing this clock. So clock will be generated and passed into the my bus. I am instantiating the DUT. Now I am going to force the value because enable should be applied for DUT, right? So I am forcing this value. So in this bus if I am accessing the signal enable and I am forcing the value of 0. After 10 units, it must be 1. After 10 units, it must be 0. So like that, I force some value. I stop the simulation here. This is what I am doing for verifying a counter. Verifying a counter. Is the idea clear, madam? Now let me run this program. So all three modules done. So what exactly happens means, it shows that the simulation has been done, and by applying the values, simulation has been finished at 170th unit, but we have not written any code here. Actually, we are supposed to write a code, initial, begin, dollar, dump file, right? So please do that one later. Dump.vcd and dollar, the top level block. I go for termination. Is the idea clear, madam? I just run this program because I just want to see the waveform. I don't monitor any command here. If I write monitor, dollar monitor means I may be observing something in the log window. I supposed to click open EP wave. I want to see the waveform after this. Save this again. Once again I run. at all I get any error, I supposed to go with token end syntax error. Testbench.sv, line number 27. So line number 27, there is an error. Dump.vct. Do we need to use double quotes, madam? Please verify once. In the syntax of our program. Test bench program already written.
Yes, sir. Yes, sir. Double quotes.
If at all any changes to be done, please make it. I'll see to that I get the results. Else it takes little more time. So what is the still error? Syntax error following Verilog source as
Semicolon.
syntax error. Test bench dot
So semicolon missing in
yes, madam.
with
Exactly.
zero.
Exactly, madam. Dump yes, right? Is it okay now? So initial block having multiple statements means I should use begin and end. Once it is done, so it shows only the signal. Top level block is specified with only clock signal, madam. Do you understand this? So I should go for 0. Save this one. Let me run again. All leaf signals also will be appearing. Okay, madam. So in this way, you can verify your program. When enable input comes, it goes the up counting. When the enable input goes low, so let me remove one of the clock because it. Let me bring it down. So clock input comes, the enable input. What is the purpose of enable input here? In what way we are trying to manipulate? Whenever enable input is there, it will update its value. When enable input 0, it will be assigned with 0. Okay. So whenever enable input is high, please look at here. Enable input is high till this time. At this instance also, enable input is high. It is go on incrementing. The moment it goes low, at this instance when it's verified, because the enable input is 0, it gives a value of 0. Okay. So it is then later once again enable input goes high, it goes on incrementing 1, 2, 3 and so on. Is that clear, madam?
Yes, sir.
So this is how the interesting fact behind the interface comes. Whenever we want to verify a complex modules, what we do means instead of specifying the ports of our design inside the module or inside the test bench or other components which covers these signals, I am calling it as a separate block called interface, where I list out the signals and I specify the direction with the help of mod port, modifying the port directions. With respect to test bench, one instance. With respect object-oriented programming, C++, process and all. So it may appear slightly different for you. Okay. Are you all able to listen to me? Are you all able to listen to me?
Yeah, we can hear you.
I'll just go through what. Okay, thank you very much. So I'll just go with what is what from the syllabus perspective. Please have a look at here. For all these things I have written example and stored. I'll share the link also. So the first one, if I consider processes, means set of sub-modules or independent modules which can be executed in
PPT,
parallel.
PPT, sir, PPT not visible, sir.
Okay, I'm sorry. I have checked because I joined again, right? Thank you. Please check now. Is it okay, ma'am?
Now visible, sir.
Okay, so processes means nothing but independent sub-modules of your program, subunits of a program. So when there is a program, it is divided into n number of processes. Each process can execute independently. Okay, the same process may also be called as threads. So please need not confuse between process and thread. The only difference in general process and thread is that process means macro module, while thread means micro module. Under that thread processes, we have multiple number of threads. Okay, there are two kinds of threads. One is parent thread, another one is child thread. Fork join, fork any, fork none. Okay, we have some more options to go. Fork join also. After fork join, actually fork join any, join none options are there. Fork join means whatever statements you have written inside, all will be executing in parallel. So all threads will execute in parallel. But the disadvantage here is that only threads inside the fork join are completed. It will go for parent thread. It will come out of that. Okay, suppose I want to skip while executing the child thread, I want to execute parent thread also. I go for none, join none. Okay, I want to execute the parent thread after completion of only any of the child thread, means I go for fork any, fork underscore any, join underscore any, join underscore none. Okay, join underscore any, join underscore none. So these are four join aspects. Next, function. As you all know, function means we can do an individual operation. Wherever it is necessary, we can call that function. Similarly, task. The difference between function and task is that function always returns only single value, while task means we can go for returning any number of values. We can return any number of values. Here we have the option to declare input and output ports. So by declaring input and output ports, you can declare any number of outputs we can obtain from the task. Void function means a function which does not any return value. When you execute, it is not going to return any value, means void function. Argument means for any function we can pass the arguments, right, as an input parameters. So that argument we can call by two methods: call by value, call by reference. So you can pass as a direct value, or you can refer to, use the statement refer, right? So what is the difference between call by value and call by reference according to the functions here is that if I call by value, the value in the main program, it will not change. Please understand, only inside the function it will change, but the value will not change outside. It will retain the old value only. If I pass by reference, means it will change inside the function as well as the global value. If at all I define a variable a, means its value will change globally also. This is called by reference. This is called by value. If I pass it as a value, means it will return the result where the main value will remain same. The variable declared outside the function will remain same. Is the idea clear? So there are examples given in the link. I will share that link also. Coming to the next session, inter-process communication can be done with the help of three options. Three options means, one is event. Event means you declare some event to be happen. So event, say for example, if I declare an event named event A, means somebody will be waiting for the event to happen. Once the event is happening, means this particular program will come into execution. Till that time, it will be in the wait stage. Is the idea clear? So when one process is completing its execution, the result may trigger another process. This is what we call it as inter-process communication. When there are multiple independent units, there may be racing problems. This may be executed first, or this may come into execution first. To prevent that, we go for different approaches. Events, mailboxes, semaphores. Event means once a particular variable changes, that's called event, change in value, then the particular process will come into active state, else it will be in the wait state. Mailbox, as I said before, somebody will be generating and putting a result into a queue, not stack. Queue means first in, first out. So whichever data you put first, that comes out first. Okay. Once the system, any other module which requires the data will access it. This is called mailbox. The other one is semaphore. Somebody wants to access the same resource. Resource R may be interested by A, another element B. Both may be interested to access this, means only one can access at a time. So we provide a key for A. Once it is utilized, it handovers the key. Then B will access the key and use it. Right? It avoids using or sharing the resources. A conflict between A and B can be avoided by using semaphores. Is the idea clear, madam? Everyone, students, is the outline clear? Inter-process communication?
Yes, sir.
Event, semaphores, mailbox. The last one, interface. Just before I told you, right? With an example I have shown, interface is nothing but declaring all the related signals inside your design into one block called interface, with a keyword interface and end interface. Okay. And inside the interface, what are the constructs you have? You have mod ports, you have clocking blocks. These are the constructs. Mod port is nothing but, instead of specifying only signal, you can specify the direction also. You can specify the direction also. We have seen, right, what are inputs, what are outputs for different scenarios. And clocking block means some of the signals should be activated only at the arrival of clock, maybe positive edge or negative edge. You want to activate or access certain signals, change certain signals in the interface only at the arrival of clock, means you declare the signal under clocking blocks. So similar to interface and end interface, here also we have the keywords like clocking and end clocking. Inside this clocking and end clocking, we declare variables that are to be activated in pass edge of clock, that are to be activated in negative edge of clock. All these declare inside the clocking blocks. This is also part of interface. Is the idea clear? Bundle is nothing but combining the signal. So under mod ports, here there are two kinds of bundles are available. Named bundles, global bundles are available, which is again part of mod ports only. And there is one more concept called virtual interface. Normally we say interface means one block. When I say virtual interface means interfacing between a static module and a dynamic module. Okay? Because static and dynamic modules cannot be interoperated in object-oriented programming. We cannot combine dynamic and static. So under this situation, we use a module called virtual interface, which helps you to combine this dynamic module and the static modules. Normally, static module means our interface is static. Our interface is generally static, which is connected to our design. Whereas dynamic means classes, objects are dynamic, right? So this classes interacts with the design means it is possible only through virtual interface. So a modified version of interface called virtual interface we use here. Is the idea clear for everyone? We have done some experiment with the interface. You can go for driver class, adding driver task. When if necessary, examples are available. I will share with you. Anything else? Anybody having questions at this moment?
Clear, sir.
Clear. Thank you very much, madam. Okay. Any questions from the audience side?
So it'd be helpful if you can share the link to
All
the
these
examples.
links I will share, because it
Right.
is once you go to here, right? I'll show you this one. My playground. Go to my playground. This is my playground, right? So all these things I have mentioned with the date. 38 means you please, even 29 also about constructor. 38 means you please take all these things. Okay. You can practice all these things: functions, void function, task, and the two types of tasks: static task, automatic task, global task, fork join, fork any, fork none, always block, like always combinational, always latch, always flip flop, event with example for triggering, semaphore, mailbox, all these things are there. Okay, all you need to do, you run the program, see the results, then you try to analyze why you are getting the results in that way. And one more interesting fact I will tell you, there is a website called chipverify.com. Chipverify.com. Have you gone through this website? Have you gone through this website?
Yes, sir. Yes, sir.
It is actually your syllabus. The syllabus is being framed as per this only, but the order may be different: semaphores, events, inter-process communication. And just before we have seen thread, fork, join, fork, none. This is enough. Fork, join, fork, any, fork, none. System Verilog threads, task, functions, all these things comes in. Inside the function, we have arguments, everything follows. So all programs I practiced here is from this link only, this website only. And they have given the expected results also. You run the program, practice it, and ask questions whenever you find time. Okay? Anything else?
Sir,
Yes, madam.
sir, in one folder, how to store all the files, sir? That it is struggling to save the files. Just for simple doubt
Pardon,
only.
madam. Pardon, madam.
If you create any folder in particular folder, how to make all the files, sir? In playground, in EDA playground.
Oh, yeah, madam. Very good question, madam. Very good question, madam. This is also we supposed to look into. I'll just click one thing, madam. I have full adder
Yes.
here. I have full adder here. I'll open it. Madam, have you seen this one? The complete
Yes,
architecture is available here. This is our design unit.
Okay, sir.
This is our design unit full adder. And in
Okay.
order to verify this, we have various blocks like a monitor block, a scoreboard block, environment block. Whenever you want to add, there is a positive symbol, madam. You please click onto that.
Yes.
A new window will open. You mention the file name with the .sv and save this one. That's all. Okay, madam?
No, sir. Under this one, sir, how? But it is not one. Only it is shows a design. The EDA playground, when open it, how we the top module, under top module, how we have to create plus symbol, it's coming, sir.
Yes,
Actually,
madam.
the doubt is the top module under how to create this one.
Madam, your design is okay, madam. Your design is on the left hand side. Your test bench program on the right hand side. Okay, madam. Only two windows will open.
In design, how where to save, sir? In design, where to save? Under design, how we create all
1 minute,
this?
1 minute, 1 minute. But I'll go for a new one, madam. Now post your question. This is our module, right?
Yes, sir.
Your design comes here. Next, this is your test bench, right?
Okay.
What is the question, madam? You type your test bench program.
In the design, where to save and the test benches you are created, no interface, all those things under this, how that is in the project under all the files like that, how to create a main folder and all.
Actually, this one supposed to be any plus symbol appears. I just want to see here. Madam, is this visible, madam?
Yes, sir.
Interface, because normally it may not visible. Interface, create file. Okay. So it creates
Okay,
a new
sir.
window, madam. You type your file here, madam. I'll go back to my old one, okay, because it appears to right. Actually, it is not visible due to this confusion. Okay, but if you zoom down, zoom out, it appears here, madam. You can type your program, right? As many you want, you add this one, madam. Is idea clear, madam?
Yes, sir.
What is your question, madam? Exactly. Is this your question?
Sir, actually, madam, what asked, we have an environment, right? So in
Yes.
that environment, we have different modules, generator, driver. So those things, those modules are available.
Yes,
I want to create one environment folder. So in that folder, I want to store all the modules. So that is the question, madam asked.
Okay. I got it, madam. I'll come back to that. Okay, but that you can understand with the example itself. Let us go to full adder. what I have opened just before. I'll take you to there. Is this visible, madam?
Yes, sir.
Full adder. This is my design, right? So in this design, what I do, this is my generator, madam. This is my generator block. Okay, I'm declaring I'm just defining it as a class. Okay, data type class, giving this name. I just specify transaction class, and I am generating some randomized function will be there. There is that random function. Only if I can go here, madam, like this. If I suppose if I want to, this is my generator will be called into driver by its name, madam, by its name. So we suppose
No, sir. Just madam, what she wants, how to save all the files in a single folder. Now I think madam got clear idea, ma'am. Actually, we have to create one file, ma'am, test bench. Then
inside that
after
you copy all the thing,
then
madam, one by one.
then
You
after
call
that,
one by one.
just you click that plus, then you can store all the files in a single folder. I think so, ma'am.
Okay, okay, ma'am. Thank you. Okay.
I think no other
Madam,
option is
the
there. I
point
think
is,
so.
madam, you can go with a separate file, madam. If you go as a separate file means by clicking this plus, it will be easy to rectify the errors where the error comes. Okay.
No, whenever we are opening the playground, the design.sv only it is coming. Once if you have saved it, then the other file also it is saved in the same design.sv in default.
Yes, madam.
So
All
like
will
that,
be
if
combined.
you
If any error
yes,
happens, right, it will show you the file name also, driver.sv, so and so line, transaction.sv, so and so line. It will show the error specific with respect to file also, because if you consider the top level block, this is my test is the top level block, right? You see here, I am accessing the environment, right? So inside the environment, if I go, the environment includes transaction class, generator class, driver class, monitor class, all these things are included. Because everything comes inside this environment, in the environment class. If I call the environment into my top level block means naturally I'm calling all the leaf cells also into that. Okay, according to your expectation, if you want to in a single page, if you copy all the things and paste it like a single file, okay, it will show the line number of your program, that's all, but it may look very complex. So it is better to go with clicking plus. You create new separate files for each one this, and you can run this. I don't get, madam, exactly folder means in what way it is folder. It is only a project, madam. You see, this is the project. Under this full header, all these things are common. So once if I open this project, under this I get all the files related to this. This is my design model. All these things are related to my test bench architecture. Okay, na, madam?
okay, sir.
If at all, if you later we will discuss it. Okay, madam? Anything else?
Okay, okay, sir.
Students, any doubts? Please ask.
I think it's lunch time for everyone.
Sir,
Yes, madam.
sir, your YouTube videos for all the topics is available, sir.
Ma'am,
No,
I
no,
will
madam.
share this.
Madam, this link I will share, madam. EDA playground link I will share, so that
Okay.
you can access all these things. Actually, a long back I created a file, madam, for another seminar I created, but it is having only limited number of links. I'll just edit it. I'll show you this, how many links I have created. A long back I created for logic gates, for multiplexer, for up-down counter, module, function, task, everything I have created for full adder. The links are available. I'll add these things. I will share the text file very soon to you. Okay?
Okay, okay, sir.
Anything else, madam? If at all you have any other questions, please feel free to type your questions to my mail ID ravi.vlsa29@gmail.com. Any general questions related to VLSA? Any question related to low power or testing or FPGA? Right? Anything related to this, like Verilog or system Verilog programming, you can post your questions here. I'm free to, or I'm happy to clarify your doubts or questions. Okay. Thank you very much for all of you. Let us consider the your way of listening. I really feel happy that you are spending your time up to 12:30 in this. Thank you very much, Madam Parvata, Madam, for giving me this opportunity. Anything is there means please ask your students to send
Sir,
queries to
your
us.
contact, sir, your contact number.
Contact number also 98424. I'm sorry.
I think it's not
Contact
coming.
number, madam. Any questions related to the programming or hardware or microprocessor, microcontroller, or anything related to low power or testing VLSI? Please post your questions. Free to post. Okay. Thank you very
Okay.
much. I have
Ma'am,
a
shall I conclude?
yes, ma'am. Yes,
Yes.
ma'am.
Thank you. Thank you, sir.
Ma'am,
Yes. Yes.
Thank you, sir. Thank you.
good afternoon to all. On behalf of the organizing community, I sincerely thank our chief guest, Dr.S. Ravi, for accepting our invitation and sharing his valuable insights with us today. And also, I extend my gratitude to our CEO, sir, principal, and HOD ma'am, faculty members, and students for their constant support and participation. A big thanks to the organizing team and volunteers for making this event a grand success. Finally, thanks to each one of us present here for your active involvement. Thank you all. Once again, a sincere thanks to our chief guest. Thank you, sir.
Thank you, sir. Actually, sir. Sir.
Madam, thank you very much, madam. Thanks for
Thank
yours.
you. Thank you. Thank you so much, sir. Thank you, participants.
Thank you.
Thank you.